Amid the ongoing Russia-Ukraine war, the US faces growing vulnerabilities in its defense infrastructure due to increasing reliance on Chinese electronics. Between 2014 and 2022, American dependence on Chinese semiconductors surged by 600%, with over 40% of semiconductors supporting Pentagon weapon systems sourced from China. In response, the Pentagon is taking decisive action to reduce this dependence, with the US Navy cutting its reliance by 40% and the Army by 17% from 2022 to 2023, marking a shift towards securing the defense supply chain. The Department of Defense is deploying cutting-edge technologies to address emerging national security threats. One major development is the successful testing of an AI-powered surveillance system by the Pentagon's Physical Security Enterprise and Analysis Group. This advanced system has achieved detection accuracy above 96%, excelling in identifying potential threats through real-time video analysis and drone surveillance. It is capable of detecting armed intruders from significant distances, recognizing behavioral anomalies, monitoring critical defense installations, and verifying security breaches automatically. In parallel, the Pentagon is establishing its first quantum computing center of excellence, set to become operational by 2025. This initiative seeks to transition quantum computing technology from research into practical military applications. The DoD is focusing on quantum algorithms to enhance machine learning capabilities, with applications in breaking asymmetric crypto systems, optimizing military operations, and improving route planning, supply chain management, and multi-UAV coordination. To counter the growing and sophisticated threats posed by quantum computing, the Pentagon is taking decisive action to bolster its cybersecurity defenses. A carefully designed implementation timeline aims to introduce quantum-resistant cryptography, fully adopt a zero-trust architecture by 2027, and enhance the security of the defense industrial base. With cryptographic modernization identified as a top priority, ongoing reviews of encryption systems ensure vulnerabilities are addressed and readiness is achieved against quantum-enabled cyber attacks. These efforts symbolize the Pentagon's unwavering determination to stay ahead of adversaries in an increasingly complex cyber domain. Amid the escalating technological competition, the Department of Defense is resolutely strengthening its cybersecurity posture. This includes adopting cutting-edge zero-trust architectures, advanced endpoint monitoring, automated data analytics, and network automation, all designed to shield critical defense systems. By integrating new capabilities such as advanced forensics and network deception techniques, the Pentagon reaffirms its commitment to not only defending national security but also maintaining technological superiority in the face of China's rapid advancements in military technology. These proactive measures reflect a sense of urgency and an unrelenting drive to protect the nation's most vital systems. As part of its broader strategy to break China's technological advantage, the Pentagon is focusing on unmanned systems and surveillance capabilities. A classified strategy has been implemented to address the pressing threats posed by unmanned systems to US personnel and facilities. This dual approach, bolstering cybersecurity and countering technological advancements, ensures that the DoD remains well-positioned to confront evolving challenges while retaining a strategic edge in an increasingly competitive global defense landscape. To bolster counter-surveillance capabilities, the Department of Defense is harnessing cutting-edge technology with unparalleled determination. Advanced counter-drone systems are being deployed across multiple operational domains, showcasing an ability to detect and track objects as small as a car from space. This leap forward in defense technology underscores the Pentagon's commitment to ensuring strategic superiority. By 2026, the plan to field thousands of inexpensive, AI-enabled autonomous vehicles will not only redefine operational dynamics but also highlight a vision of innovation that protects lives and deters adversaries. These vehicles, equipped with capabilities like small, unmanned aerial system detection, electronic warfare countermeasures, advanced sensors, and real-time threat assessment, embody the future of modern defense. At the heart of this transformation lies the Replicator Initiative, a bold and ambitious strategy to deploy thousands of autonomous systems across multiple domains within just 18 to 24 months. These attainable systems, designed for cost-effectiveness, adaptability, rapid deployment, and risk minimization, reflect a focused and dynamic response to emerging threats. By leveraging these advanced technology, the Department of Defense is not only neutralizing China's numerical advantage in military, mass and personnel, but also inspiring confidence in a future where innovation meets resilience. This strategic drive is a powerful reminder of the unyielding commitment to protect and preserve national security in an ever-evolving global landscape. The Pentagon strategy also emphasizes innovation and international collaboration. Through the establishment of the Joint Counter-Small UAS Office, the DoD is coordinating counter-drone efforts across all military branches. With $145 billion allocated for research and development and $170 billion for procurement, the U.S. is committed to maintaining technological superiority. Rather than competing with China's focus on quantity, the U.S. strategy prioritizes innovation, leveraging advanced technologies and superior operational concepts to outthink and outmaneuver adversaries. This approach underscores the Defense Department's determination to address the challenges of China's rapid military modernization by leveraging technological excellence and fostering global partnerships. As part of these efforts, the Pentagon has prioritized a comprehensive overhaul of supply chain security to protect critical military infrastructure and maintain a strategic edge. Central to this initiative is the Integrated Logistics System Supply, ILSS, a cutting-edge logistics platform that currently tracks over 35 million assets valued at $18 billion across 7 million warehouse locations. By securing military assets against potential threats, the ILSS establishes a robust and efficient foundation for safeguarding the supply chain, further reinforcing the Defense Department's overarching strategy for enduring technological and operational superiority. The ILSS processes over 10 million transactions daily, including 5 million orders facilitated by automated verification protocols. Advanced features enable real-time identification of optimal enterprise sources, ensuring accurate and automated fulfillment of critical supplies. With capabilities such as event-based automatic sourcing, enterprise connectivity across 46 systems, and automated functional testing involving 17,000 end-to-end tests, the platform offers real-time enterprise asset visibility and unparalleled operational efficiency. To further enhance security, the Defense Department has integrated blockchain technology into its supply chain management. This tamper-resistant system provides a collaborative ledger for transactional records, secure two-way encrypted validation between senders and receivers, and permanent record-keeping for audit accountability. Blockchain implementation minimizes human error while ensuring the quality and authenticity of supply-related processes, including manufacturing, end-user item distribution, and parts availability tracking. The Defense Logistics Agency has also established an enterprise architecture that continuously identifies, assesses, and mitigates threats to the global supply chain. AI-powered risk assessment tools provide real-time visibility, enabling defense organizations to make informed decisions about potential risks, particularly those linked to foreign threats, such as those originating from China. The Defense Department's commitment to securing its supply chain through advanced technologies, such as IoT-enabled real-time monitoring and blockchain integration, directly complements its efforts to protect critical military hardware. By ensuring accurate tracking of goods and strengthening supply chain resilience, the department establishes a robust foundation for safeguarding essential components and systems against potential threats. This dedication to security extends to military hardware protection, where the department has implemented multi-layered measures to defend against sophisticated threats, particularly those posed by China's advanced weapon systems. Through innovations like component-level authentication, tamper detection protocols, and comprehensive system monitoring, the Defense Department ensures the integrity of military operations while reinforcing its broader strategy to maintain operational superiority in an increasingly complex global security environment. One cornerstone of this strategy is the use of advanced DNA marking technology by the Defense Logistics Agency for authenticating electronic components. This technology leverages encrypted DNA sequences derived from plant material, allowing for quick and accurate verification using light-based scanning. Any tampering results in visible distortions of the DNA mark, ensuring reliable detection. With optical surface layer analysis, real-time verification, and automated confirmation, this system significantly enhances component security. In response to increasing demands for secure cryptographic processing, the Pentagon has deployed hardware security modules, HSMs. These tamper-resistant environments, certified to FIPS 142 standards, support secure cryptographic key management, authentication for accessing classified data, and the integrity verification of boot code and firmware. Detailed monitoring of encryption key usage further strengthens the system's resilience to potential breaches. To prevent the exploitation of critical program information in U.S. weapons systems, the department has established an anti-tamper framework. This system operates through 4 key mechanisms: deterring potential exploitation, impeding unauthorized access, detecting tampering events, and automating responses to breaches. These protocols align with the Pentagon's adoption of Zero Trust principles, which involve 152 distinct security activities for continuous monitoring and authentication. By assuming that all networks are inherently compromised, the Zero Trust approach ensures constant verification of system integrity. At the hardware level, continuous multi-factor authentication (CMFA) systems enhance security through advanced biometric analysis, including facial recognition, voice authentication, and gate pattern analysis. These capabilities enable seamless authentication across diverse Department of Defense networks, supporting both operational and administrative environments. The Defense Advanced Research Projects Agency, DARPA, has contributed to these efforts through its Supply Chain Hardware Integrity for Electronics Defense SHIELD program. One notable innovation is DLED technology, a microscopic verification system embedded during component manufacturing. This system allows untrained operators to authenticate any Department of Defense component using a simple handheld probe, further reinforcing the Pentagon's comprehensive approach to hardware security. Together, these initiatives represent a multifaceted defense strategy aimed at preserving the integrity of U.S. military systems and enhancing their resilience in the face of evolving threats. Central to this approach is the Pentagon's implementation of comprehensive safeguards for advanced weapons systems, designed to counter emerging threats from adversarial nations and protect critical military operations. Recent testing has demonstrated the effectiveness of these measures, with AI-powered surveillance systems achieving detection accuracy exceeding 96% in identifying potential security breaches. This exceptional performance underscores the Department of Defense's unwavering commitment to leveraging cutting-edge technologies to secure national defense and maintain operational superiority in an increasingly complex global threat environment. To protect critical weapon systems, the department has adopted multi-layered security measures that include real-time AI-enabled threat monitoring, automated verification of anomalies, continuous system integrity assessments, and advanced forensic capabilities. These protective measures function within an integrated framework that combines human oversight with automated security protocols. Despite these advancements, the Pentagon's Chief Information Security Officer has identified persistent vulnerabilities in certain programs that could potentially compromise weapons systems, necessitating ongoing vigilance and enhancement. Anti-tamper mechanisms form a vital part of the Defense Department's strategy to safeguard critical program information in weapons systems. This framework operates through a 4-step approach: deterring potential exploitation, implementing impediment measures, detecting unauthorized access, and automating responses to security breaches. With billions of dollars invested in sophisticated weapon systems, these mechanisms are essential for preventing exploitation during export, theft, or combat losses. Secure communications protocols are another cornerstone of the Pentagon's strategy. The department maintains strict control over nuclear command and communications, adhering to a mandatory human-in-the-loop policy for all critical weapons deployment decisions. Encrypted key distribution protocols support secure, real-time communication between geographically dispersed units, while the Communications Security Modernization Program processes over 10 million secure transactions daily through advanced networked key management infrastructure capabilities. To address vulnerabilities exposed by testing, such as poor password management and unencrypted communications, the Pentagon has embraced a zero-trust architecture. This approach requires thorough threat analyses and vulnerability assessments before deploying new weapons systems, Recognizing the limitations of traditional security approaches, the department has developed additional anti-tamper resources, including online training courses, updated acquisition policies, implementation guidebooks, technology databases, and web-based information portals. These measures underscore the Pentagon's proactive approach to safeguarding its weapons systems and infrastructure against evolving threats, ensuring that the U.S. military maintains its technological and operational superiority in an increasingly complex global security landscape. Building on this commitment to resilience and innovation, the Department of Defense has also introduced a groundbreaking initiative to bolster national security through enhanced industrial collaboration. The Department of Defense has taken a groundbreaking step to strengthen national security by unveiling its first National Defense Industrial Strategy, a comprehensive framework for fostering collaboration between government and private sector entities. This strategy represents a fundamental shift in the Pentagon's approach to industrial partnerships, focusing on countering emerging threats while ensuring the long-term resilience and modernization of the U.S. defense industrial base. At the heart of this strategy is the emphasis on public-private partnerships. These initiatives provide significant strategic advantages, including risk-sharing mechanisms, co-funding opportunities for critical projects, enhanced supply chain resilience, expanded production capabilities, and strengthened workforce development. Economic security agreements and mechanisms for sharing technology with allies form the cornerstone of this approach, establishing a robust foundation for sustained industrial cooperation while maintaining a competitive edge in advanced weapons development. To support these goals, the Pentagon has revolutionized information sharing practices through the Secret and Below Releasable Environment (SABRE) system. This advanced platform facilitates seamless communication with international partners, offering capabilities such as document sharing, combined fire coordination, joint medical evacuation, and mission-critical applications. The Mission Partner Environment (MPE) further enhances coalition operations by enabling real-time data sharing across multiple domains, processing millions of secure transactions daily to support joint efforts with NATO allies and other strategic partners. International collaboration is also a central pillar of the strategy. The Defense Department has intensified joint research initiatives, with a particular focus on the AUKUS trilateral partnership comprising Australia, the United Kingdom, and the United States. These efforts prioritize the co-production of weapons systems and cross-border industrial collaboration, addressing shared security challenges through innovation. In the Indo-Pacific, the department has implemented new mechanisms for defense industrial cooperation, breaking down national barriers to integrate industries across partner nations and building a resilient supply chain network. Additionally, the Defense Innovation Unit has expanded its global reach, maintaining relationships with innovation organizations in key partner nations, including the United Kingdom, Australia, and India. These partnerships accelerate the adoption of advanced technologies and facilitate the shared development of cutting-edge military capabilities. Through this comprehensive strategy, the Department of Defense is fostering an interconnected and resilient defense industrial ecosystem, ensuring that the United States and its allies remain at the forefront of technological innovation and security. This collaborative approach directly complements the department's multi-year implementation timeline, which is meticulously structured to address emerging threats while bolstering the nation's defense capabilities. The Department of Defense has introduced a comprehensive, multi-year strategy to deploy advanced defense technologies and countermeasures, particularly addressing emerging threats from adversarial nations like China. This detailed implementation plan is structured into distinct phases, each designed to achieve critical security objectives while ensuring the long-term technological and operational superiority of the U.S. military. The initial phase, spanning through fiscal year 2024, focuses on immediate security measures to address urgent challenges. The Joint Artificial Intelligence Center has launched 15 proof-of-concept pilots aimed at demonstrating rapid deployment capabilities in areas such as automated threat detection, enhanced cybersecurity, supply chain verification, and real-time monitoring. To support these efforts, the department allocated significant resources, including $100 million for 10 programs in 2022 and $150 million for 11 programs in 2023 through the program to accelerate the procurement and fielding of innovative technologies. These measures establish a strong foundation for addressing current vulnerabilities. The medium-term phase, continuing through 2025, emphasizes the expansion of technological capabilities and infrastructure. With investments in artificial intelligence increasing from $600 million in 2016 to $8 billion in 2024, the Pentagon is accelerating the adoption of innovative solutions. This phase focuses on fostering a culture of technological adoption, strengthening information systems, implementing advanced technologies, and integrating zero-trust principles into defense operations. The Defense Innovation Unit has received nearly $1 billion to scale these advancements, ensuring that innovative solutions are effectively incorporated across military domains. The final phase, extending through 27, centers on long-term integration and sustained enhancement of defense systems. A significant milestone during this phase is achieving comprehensive zero-trust implementation, a critical advancement in cybersecurity. The strategy includes the realization of 91 defined capability outcomes to secure networks and protect against sophisticated threats. Regular oversight by the Chief Digital and Artificial Intelligence Office ensures adaptive progress, while annual implementation plans from individual components promote accountability and consistent development. Additionally, the department's approach to rapid experimentation and immediate feedback from warfighters has proven highly effective, with nearly 70% of projects under the Rapid Defense Experimentation Reserve transitioning successfully into operational use. This unified and methodical strategy reflects the Department of Defense's commitment to building a resilient defense infrastructure capable of addressing immediate challenges, expanding technological capabilities, and securing long-term operational superiority. By adopting a future-focused approach, the Pentagon ensures that U.S. military systems remain prepared to confront an increasingly complex global security landscape. Rapid technological advancements and shifting threats have necessitated a transformative approach to defense innovation. The Department of Defense has implemented future-proofing measures designed to enhance the adaptability and resilience of its systems. Recognizing the limitations of traditional methodologies, the Pentagon's strategy focuses on integrating advanced technologies, fostering collaboration, and accelerating modernization efforts to maintain a decisive edge in modern warfare. The Defense Department is actively developing an innovation ecosystem that connects innovators directly with warfighters, accelerating the adoption of advanced solutions. These efforts focus on critical capabilities, including AI-enabled autonomous systems, quantum-resistant cryptography, multi-domain operational platform, integrated threat detection systems, and adaptive cyber defense mechanisms. By enabling real-time threat assessment and response across all 11 combatant commands, the department ensures its preparedness for dynamic and unpredictable challenges. In response to the need for greater speed and adaptability, the Pentagon has overhauled its security framework, emphasizing 5 strategic priorities: integrating commercial technologies, developing autonomous capabilities, enhancing cyber resilience, deploying quantum-resistant systems, and implementing AI-powered defense mechanisms. Through its automated systems, which process over 10 million transactions daily, the Defense Department demonstrates its commitment to rapid response and operational efficiency. To further enhance flexibility, the department is transitioning to a modular open systems architecture, enabling swift updates and replacements for system components. The Defense Department's continuous innovation strategy is rooted in digital engineering, agile software development, and enhanced testing through digital simulations. This approach has already shown success, with the Air Force leveraging digital engineering for next-generation air dominance fighters and the Army selecting competition winners based on digital designs. These advancements underscore the Pentagon's focus on streamlining design and implementation processes for faster deployment of critical technologies. To strengthen its innovation ecosystem, the Pentagon fosters collaboration across government, industry, and academia by offering rotational opportunities for expertise development. The Chief Digital and Artificial Intelligence Office spearheads data-centric modernization efforts, delivering advanced capabilities to the Joint Force. Task Force Lima, established in 2023, explores the integration of generative AI tools while addressing associated risks, ensuring these technologies are responsibly adopted. This strategic elevation of the Defense Innovation Unit underscores the Pentagon's unwavering commitment to staying ahead in a rapidly evolving technological landscape. As the Department of Defense continues to prioritize innovation and adaptability, what emerging technologies do you think will shape the future of national security?